Going back to this, right?
You should pinch it and it should be.
Yeah, just they don't have touch screen. Oh, this guy.
Yeah. Then push it to the other side. Yeah.
But this makes sense. They're not supposed to do that. Cool, thank you. We needed to import the point class because it's not there by default, right? And then we create variables, we declare variables the same way as if they were ints, right? In this case, they're points, so I do point p instead of int a or I or something like that. However, here's the magic. I call new, right? And let me do this so you can actually read it. New, then the name of the class, point, and then it has arguments to the constructor. This creates a new object in memory, right? That object has an identity, has a state. Its state is that its x is 3 and its y is 5. And then I assign that object to the variable p. Does this idea make sense? Normally we do this, we could create the object and then not assign it to a variable. Then there's not much we can do with it, but we can.
What does aug stand for?
I have no clue.
Sort of remember.
Something widget toolkit,
Okay.
because it was for graphics. For me, it's just a super simple class that's standard, so I don't have to define it.
So what makes that not a variable? Because can we just say the variable is not point do?
The variable refers to that point, is that point, but there is different meanings of each. You can say the variable is that point, but you could do this. Point P2 equals P.
Just abstract window toolkit.
And so, sorry?
Abstract window toolkit.
Abstract window toolkit, thank you. That was
Not
the
that
A
I
in
remember that
AWT.
way.
Now you have two variables, P and P2, and they both refer to the same object. Right? So you get aliasing and you can get confused and you can, right? What can I do to an object, right? Given a reference to an object, which is normally a variable, right? So I can use the period, the dot operator, to access its members, either its variables or its methods. A point happens to have two variables, two instance variables, x and y. So p.x will return an int, and p.y will return a different int, right? I can actually assign to this. I can assign to member variables, and we'll see you can't always do that, but. So now if I print p, I have x equals 3 and y equals 45, right? So if I do p.y, now I'm going to get 45. p2 points to the exact same object, right? So when I do p2.y, what's it going to give me?
Y is 45.
Yes. Because they are the exact same object.
So for like a class, you don't always have to say new to make a new one. You could say P2 equals P. You don't have to say new P2.
Wait, those are two different things. For creating an instance of a class, for creating an object, you have to say new.
So
right?
when you say P2 equals P, that's not creating a new instance?
There is no new instance, right? The first instance that I created is there, except that now I can reference it two ways. Either call it P or call it P2.
Also, it's just a new name for the same instance. Okay.
Yes. And you do create a new instance with the new operator, whether you assign it to a variable or not. So I can do new point 3, 4, and that created a new instance, and then I didn't do anything with it.
Since you didn't give it a name.
Well, I didn't assign it to a variable,
Yeah.
right? the variables are different from the objects that they refer to. With something like an int, you don't terribly care, because an int is an int, but in here, it's gonna be important. That distinction is gonna be important. Variables are not the same as objects, right? Variables are names for things. And they have a scope, they live for a little while, and then they get out, right? Whereas objects are things in memory. Am I making some sense? We'll do a million of these so that they stick, hopefully. We can also call methods. So a point has a getX method that actually returns a double. It is fairly common for most classes in Java to have get whatever for the variables, right? So if your variable is x, you'd have getX, and that's camel cased. And you could do setX. Oops. Doesn't have setX. Never mind. It is common to have setX, but points don't. Points are immutable. Actually, they are not immutable because you can go change directly and do p.x equals 6. But they don't have a set. It is fairly common for classes to have get whatever and set whatever. Is there? There's a bunch of things that I can do. Move. Actually, let's print p again. P is 645. P dot move 4 minus 10. So now p. Oh, move actually sets both x and y. Sorry, I thought it was a relative move.
Would you have to get the different commands that are available?
Tab. Java REPL has tab. In IntelliJ, you do, I think, control space or something like that. I haven't used Eclipse in months, so I don't know. My fingers usually remember once I'm in the editor, but I use Linux at work and a Mac otherwise. And so the fingers don't work the same way. But in Java REPL, tab does it.
So what would be the difference in putting the get location as opposed to just recalling what p was?
It's almost the same, but they did it because we'll see later there is inheritance, and so you could have, let me do this, import java.awt.rectangle. That's another class, right? So I can do rectangle r equals new rectangle, say 10, 10, 20, 30. So it starts at 10, 10, and has width of 20 and height of 30. But I can probably do r.getLocation. No, never mind. I'm lying to you. Yeah, there is. R, which is a rectangle, has a get location that returns a point. So when they're trying to do this kind of generalization, they say, oh, a point should also have a get location.
Okay.
So it's not terribly useful on a point, but
What's the res 13?
it's whatever name Java REPL decides to give to that thing.
Oh, okay. To give to what?
To that thing. This, right, actually is result 14.
Oh, result 4. Okay, it's a Java
It's-
REPL thing. Okay.
It's a Java REPL thing.
I was like, what is that? I don't get it.
It is
All
whatever Java REPL needs to, because Java REPL needs to give it a name so it can do things to it. So, to create a point, we do new point, right? To create whatever kind of object, you use new, the name of the class, and then whatever parameters the constructor has. How do you know what parameters does the constructor have? Bing is your friend. Google that thing or whatever, right? Look at the code maybe, or look at documentation usually, especially for standard classes. But so calling new actually creates a new object in memory and yields that object, right? Returns that object. No, return unless you do it from a method or function. Now, normally you want to do something with the object, so you would actually assign them to variables, right? The act of creating a variable and assigning to it is separate from the act of creating the object, right? So in there we actually have three things. We create a new object, we create a new variable, and we assign the value to the variable. What happens if we don't assign a value?
It's a valueless object.
Well, oops. Oh, that is horrible. Java REPL is horrible. It actually has null, a special thing. That's in Java you don't have to put it, but in Java REPL you do, I guess. Null is a special value that means this object points, this variable points nowhere. An object can never be null. A variable can. Does that make sense?
So an object can't be null because it has to be unique, and so then two things could be null, so therefore it's not unique.
Exactly. But the variable can put an object, by definition, null is the special thing for no object. So you can't have an object that's no object.
Well, so wait, so when I create a new point P3 with no
Initialization.
no coordinates, it just, and then I say P3, it says 0, 0 is what it gives me.
No.
Or did I do
No.
something wrong maybe?
Yes. Let's me do. Did we do this? This was a tiny thing, right? Let's do it in real Java. Java REPL is messing us up. We did is even and stuff like that, right? Yep. What happened? It disappeared. We're talking about this stuff, right? Here we would do import java.aug point rectangle if I do this, right?
Oh, it's gonna.
Variable p may not have been initialized. Yeah,
You
of
never
course.
said new P though.
Yes, I didn't say new. Yeah. Oh, and that may be why. Okay. If you say new, then that's not null. That's a new point that you're creating.
So it's gonna have 0, 0. Oh, okay. So it's not
Yes.
gonna have like null values. It will default to some value. because-
Well, it doesn't default, right? You are calling new. If you call new, then this will create a new object.
How does it know that X and Y are 0 and 0?
The point defines what does it do when you
Yeah.
call it with nothing.
Okay.
The point class decides that those should be 0, 0. And we don't have the code of the point class.
But it doesn't even necessarily have to do that. It could create like a point that doesn't have X and Y when you do that. It would be kind of
X and Y are ints, so they're primitives. They have to have a value. Yeah, the int will have, actually, objects also, like variable references may have value, it's just null,
Okay.
right?
So you could even get it to return like null by default.
No, ints can never be null.
Oh,
Only,
okay.
only objects can be null. If they were
Okay.
integers, they could, but yeah.
Alright, but the object can be null.
Objects,
Okay.
variables can be null.
Or a variable can okay, I'm sorry.
Sorry,
Getting
no,
mixed up.
I'm
trying to get it
confusing
right.
you guys. Variables can be null,
Variables
right?
can be null.
Does this make sense?
I haven't really done much. Is point p the whole variable, or is just p the name of the variable?
P is the name of the variable.
Okay.
Just like when you do int a,
Right. Or
a is the name of the variable. Yeah.
So what would point be? Would that be the class?
Point is the class.
Okay.
Yes. Is the class in this case, since we are doing objects, is always a class. So we can, did we do this? Let's do dimension. A dimension has width and height. And so for this particular class, because rectangle has a constructor that takes a point and a dimension, right, we would have created a rectangle. Oops. Maybe. Oh, it is there. With x10, y20, and then y width 5 and height 10. Makes sense-ish? We can also combine all sorts of things, right? Actually, what happens if I do p.x equals 100 now? What would happen to the rectangle? We don't know, right? But hopefully it copies the stuff. Yeah, so it copied it, right? R didn't change. R made a copy of that x and y. If we print the thing, then that is horrible. Maybe that's what's killing me. So the point now has 100 as x, but the rectangle is still at 10.
How does that change the x value for the rectangle?
If you want to, then what do? In this particular case, because the rectangle class lets you change its x. I hate this thing.
I just would assume that since we set a value for p and then we change the x value on p, that it would change it since it's.
It depends on the class. They may choose to not make a copy, but the rectangle class, the way they implemented it, right? It makes a copy of the x and y, which would be my assumption, but they could do it the other way.
If you put the p.x up above, you know, like right after, then that would change the rectangle
Right after where?
Like, say you say new point P 1020 P dot X equals 100. You change,
Yes,
P and
but
then
that's because
you
when
do
I
it first.
passed it, at the time that I passed it, that was the value.
Yeah,
If I change it again, then it doesn't take it.
yeah.
This is the problem with changing state. You need to remember what happened when. Right? Last class we were talking about functions and purity, right? When you start changing state, then you need to remember what happens when.
That's not a problem. It helps you do more.
Well, it's a problem once you have 5,000 lines and for loops and things start executing and then you don't remember your name, much less what happened when. So it's right, it's not you do it, it's just you need to be careful. Does this make sense? We talked about null, we talked about objects, right? Objects have state, so we can reference each field or its instance variables. Points have x and y, dimensions have width and height, rectangle has all four. We can call methods. Let's see. Is this still alive? Nah. And what happens? God, I need to import. Let me call it P then. One of the methods is translate. And what that does is it moves the point. So it was 1010, I translate, oh sorry, it was 1020, I translate by 1010, so now it's 2030. Does that make sense?
And that's different from P move because you had to specify the point it was going to.
In move, yeah, you specify the point it goes to. In translate, it's relative.
Gotcha.
This is just adding, like adding to the point, basically.
Yes.
Can you subtract?
What's subtracting?
Let me say, like, you have two different points, you just subtract them to find the
Oh,
difference.
let's see. Let's see. P to translate P. Does that work? No, there is no translate for points. Right? If I can I subtract? Yeah. Subtract is just adding negatives, right?
Could you do like P and then P1 and then
I could do P1 equals new point 100, 200. And then I could do stuff like P1 dot translate P dot or minus P dot X minus P dot Y. Is that what you meant? So you can combine this any way you want. Translate is a void method, so you can't use it in expressions, right? So you need to do sequencing. You need to do this, then that. There is, yeah. Other things, when you get home, play with these things, or if you have a computer right now, play with these things. Now, there is a bunch of common methods and operators on objects. We have equal, equal. What does equal, equal do as an operator?
Compare.
Compares two things, right? Well, let's do this. P point P equals new point 1010 or 10, yeah, let's do 1010. And then P2 equals new point 1010. What would this print? Is P equal to P2?
So,
Yeah, because they're
Maybe. Ooh, false. Why?
two different objects.
Two different objects, right? Equal equal checks are this the same object. Not objects with the same state, but the same object. Are this the same bottle of water, right? As opposed to two bottles containing the same amount of water.
So how could you compare
That's good.
two objects?
There is dot equals. P dot equals P2, which I could almost write like this.
So when you compare variables, it's not comparing, it's never comparing to see if they're the same variable, it's comparing their values.
Yes.
But for objects, it's never comparing the value of whatever the object
No, it is
has.
comparing. It is comparing the value of the variables. It's just the value is different. They are not the same object.
What precisely is different about the objects? Just
They are two different
they're
objects.
not
If I
the same.
change one, the other one didn't change.
Okay, but if I say like int x is 2, int y equals 2, and I compare x and y,
Because numbers don't have an identity. This 2 is the same as this 2, right? But this house is not the same as this house, this other house, right? If I go to a neighborhood and I build 100 identical houses, right?
so
Each house is different to each other. They're not the same house. If I go on bit one,
so no variable has an identity, only objects have identity.
variables have names, right? The name of the variable.
Okay, so So
But-
he said if the name of x is equal to the name
Well,
of
but-
y, I would say no.
You can just see it, so there is no point in comparing names of variables. You can see the name, right? So equal checks, are they the exact same object, right? Dot equals check, do they have the same value? Who decides whether two things are the same value? Well, double equal, right, is always, are they the same object? When you ask these 2 points, who decides whether they are the same value or not? No, that's just whether they're the same point or not, but not the same state, right? P2 and P are not the same memory location, but equals return true. Why? The class decides what it considers equal, right? Is 100 equal to 100.1? How about 100.0001? They're the same as that. The class decides, right? The class decides what's equal or not. Does that make sense?
So you're saying some classes are gonna be more stringent about it being exact?
Some classes will do all sorts of horrible things. In fact, another class, let's see, it's big decimal. We were talking about ints. Another class that I hate, but I use all the time, is big decimal. Big decimal represents kind of unlimited-ish precision. And it actually keeps the precision, not like floats. It's not actually unlimited, but I can create another new decimal, right? Are they the same? Well, BD equals BD2, what should I get? False. They are not the same object. Are they equal?
Yes.
Maybe. In this case, they are not, because 0.50 is not the same as 0.5. Why? Because they, right, the designers of the class decided that they are not equal.
So are you saying two classes could never be equal?
Two objects of different classes?
No, I mean object could never be equal.
What do you mean two objects could never? Could two objects, two different objects, by definition are not the same object? Because we specify that they're different, right? Two object references could refer to the same object. You don't know, that's what equal checks, right? Two instances are not the same object, they're different. They may be equal, but not the same. If you have a twin, right, an identical twin, they may be identical to you, they are not you, right? If you get hurt, you suffer, not your twin, right? I mean, there is this thing of things in the real world have an identity separate from their state. They may look identical, you go to a factory, you build 100 pens, but if I break this pen, I broke this pen, not the other one. So, dot equals checks for are they the same, in whichever way the class decides to implement the same. Equal checks are they the same object, are they necessarily the same, right? So if two objects have equal, then equals should return the same. Yeah, the class can decide whatever. But that would, right, that would not change. They're the same object. If I change one, the other one also changed. Whereas, if I do, and I cannot do it with points, right, I go change 1 point, now they are not equal anymore. Does that idea make sense? How do you make it make more sense? Yeah. Go do 1,000,000 of this, right? Go play with Java REPL, define it, put it, add it, right? Create 5 objects. What happens? Are they the same? Are they equal? What other things you can do, right?
So is big decimal, is the value of a string, or is that just the way you format it?
That's the way, so I don't get confused, because what happens when you pass is this gonna be converted by Java into 0.5? Actually, it got converted by Java into that number, right? Which is not what I typed. Whereas if I put it as a string,
You get what you want.
I hopefully get what I want.
Okay.
So by using strings, I don't get confused and I don't confuse you.
Okay.
This is kind of the preferred way to deal with money in Java.
Makes sense.
So, because you don't get this. What does an accountant do when they see this stuff?
Right.
Go find the fraction of a penny, right? Like here's a nickel, don't bug me. No, why is that different? Because that may mean actually that you got a completely different answer that just happens to be close. Does this idea make sense? We know what we are doing with objects. We can declare objects. We can declare variables. We can create objects. How do we create an object? Instantiate an object or create an instance of an object? What do we do? New, right? We have equal. We have toString, which is a what these guys are doing to print this, right? So I can do bd.toString, and that will actually convert it to a string. We actually have compare to, and compare to returns positive if one is bigger, negative if smaller, and 0 is equal-ish. So BD is 2.5 and BD2 is 0.49. So BD dot compare to BD2 would give me 1 because BD is bigger than BD2, right? And so BD2 dot compare to BD should give me minus, well, a negative number, -1, and then BD2 dot compare to BD2 should give me 0, and each class is free to do whatever the heck they want. So if I do BD2 equals new big decimal 2.5, I can ask BD dot equals actually 2.50. I can ask BD dot equals BD2, and we saw that it would say false. What does BD dot compare to BD2 return? Should return -1 if it's bigger, -1 if it's smaller, 1 if it's bigger, or 0 if they are equal. Ah, they got backed into a corner. They actually return 0. Yeah. And so whoever defines the class can do whatever the heck they want. Normally, equals means the state is the same in whichever way they think about the state being the same. Compared to does kind of at the same time, greater than, less than, and equal. ToString returns a string representation of the object. Clone, and I should have put the things. Clone creates a copy of the object. So if I have P, do I still have P? Yes, I can do P2 point P2 equals P dot clone. And I had to cast it to a point. So that gave me a different point. So now P dot equals P2 should return true. But if I do P dot, if I do P, what was P? 1010. If I do P dot X equals 100, P2 is still 1010. It made a copy of.
Did it create a new one, or did it just?
It creates a new one, but without calling new. Right? Internally, it calls new.
Okay.
Creates a new one with the same state.
And even though it's cloned, it's still its own identity.
It's not the same. It's a new object. It's a new instance of the thing. Although, again, most of this stuff is definable by the classes, so sometimes they do weird stuff.
Still, if you copy compare the P1 and P2, it's going to give you false.
Now, yeah, because I changed P.
No.
Yeah.
But clone is like a standard method, like get and set. So when you see clone, you can basically assume that it will be a new. It won't be somebody else's
Yes.
interpretation. Okay.
Yeah.
As long as they're good.
Yes-ish. Exactly. Yes-ish. You still need to go look at the library to make sure that they didn't mess it up. But what happens when the object disappears? What happens if I do new 0.45? Gets memory, right? Creates a new point, and then I don't do anything with that point. I printed it and then that's it. Can I refer to it? Can I use it in any way? No, because I didn't keep track of where it is, right? So does it matter what happens to it? Not much, except for one thing. My memory is finite, right? Eventually I run out of it. So what happens? What does Java do? And this is different from C and C++. In Java, there is automatic garbage collection. At some point in time, whenever the JVM feels like it, right, it will say, oh, I need memory. Let me go see, oh, nobody's using this guy, so let me put it back into the free memory pool. Does that make sense? And that is cool and magical and makes your, allows you to be a lot lazier when you're programming, because it will eventually get taken, right? It will eventually be returned. It's not quite the same. In C++, you can get a lot more speed because you are controlling exactly when is memory being allocated and not and things like that. But this allows you to be a lot lazier with memory and memory allocations, which is really, really, really good. Lazy is good. Computers are really good at keeping track of stuff. It's good if they do it. Yeah, this is what I really wanted to talk about, but we're basically done with time. What happens? Let me just prime your brain, and we'll talk about it next class. We'll be talking about objects and then about functions again. When I pass a primitive to a function, right? Imagine that I have this function. Try to change primitive. I pass it an int. And in here I say a equals 2 times a. What did I change? I changed the parameter, but I didn't change whoever called me. Right? When they called me, they made a copy of that int, and I played with my copy. Does that idea make sense? What happens when I pass an object? Well, if I change the reference to the object, then that's okay. But if I change the state of the object, I really changed my parameter. I changed whoever called me. Does that make sense? So that is important. So this would not change. It changes this reference P, but it doesn't actually change the point outside. If I call a function that changes the state of my parameter, then the parameter actually changed. The state actually changed. Does that make sense? And we'll go over it again next class. We'll start from here and we'll really go deep and define more classes and things. Let me also mention one other thing. Strings are weird. They are classes, right? There is a class called string. That's why string is capital S, as opposed to a lowercase e for int and boolean. But Java does magic so that they are immutable and weird. So string constants will actually get you the same object. The compiler makes sure that you get the exact same object if you have string constants. So in Java, a equals a would return true. Because the compiler will make sure that those will not create two objects, but we can do new string a, and then that would be false. So strings are weird. We'll talk about them next week. Just wanted to mention that they're weird. We'll see them in all their weirdness next class. Assignment 1 is due this Sunday, right? We start being slightly pickier with deadlines. So I'll see you guys on Monday.